Hello everyone, my name is GEETHIKA. I'm currently pursuing my BTech in BBIT. I'm from CSC. My roll number is 592. Today in this session, I'm going to discuss about addressing modes. Let us see the topics today we want to discuss. What is an addressing mode? What is effective address? Different types of addressing modes with examples. Let us see what is an addressing mode first. The term addressing modes refers to the way in which the operand of an instruction is specified. Means the instruction which consists of the effective address or the location of the operand is called as addressing mode. Next, what is effective address? It means effective address is the exact location of the operand in the memory location in which operand is present actually. Means if you try to say like if you denoting a variable 4 means the exact memory location of the variable will be considered as the effective address of storing 4. Here, there are different types of addressing modes, but today I want to discuss 5 types of addressing modes. First one is immediate addressing mode, and the next one direct addressing mode, indirect addressing mode, register direct addressing mode, register indirect addressing mode. Let us see immediate addressing mode first. Here, immediate addressing mode means the operand is defined in the instruction itself. Means if you try to specify an opcode and an operand in an instruction box, then operand will be specified in that instruction box itself. This mode instruction has an operand field instead of an address field. Actually, in the instruction field will contain an opcode and addressing field, but in immediate addressing mode will contain opcode along with operand. Now, the operand field contains the actual operand used with the specified operation in the instruction. The immediate mode instructions help initialize registers to constant value. For example, if you take move #200 to R0, in this, the opcode is move. And if you try to specify #200 means it is nothing but operand. #200 specifies that it is an operand. 200 is an operand. So we'll move 200 to R0 register. The next example is add #10 to R0. If you try to analyze this, #10 means operand. We'll add this 10 value of 10 to register R0 value. Means R0 is an address. We'll get the operand in the R0 and we will add this 10 to that value. Next one, direct addressing mode. The effective address of the operand resides in the address field of the instruction itself. As earlier we have seen, immediate addressing mode means we have taken an opcode along with the operand. But in this direct addressing mode, we'll take opcode along with effective address. Or we can easily say addressing mode. This addressing mode is nothing but effective address. In this direct addressing mode, the operand resides in the memory and the address field of the instruction gives its address. Only one reference to the memory is required to fetch the operand. It is also known as absolute addressing mode. Means if you take addressing mode in this direct addressing mode, it will consider as effective address, right? Only one reference to the memory is taken. Means directly we will go to the memory and we will fetch the data. So, for example, add A comma B. The operand here, the operand in the memory location A is added with the operand of location B, and the result is stored in B again. Next one, indirect addressing mode. Indirect addressing mode is nothing but if you take an opcode along with addressing mode, this addressing mode consists of effective address, not the operand. Again, the effective address consists of operand. So here we will use 2 references. Let us see. The address field of the instruction gives the address of the memory location that contains the effective address of the operand. 2 references to the memory are required to fetch the operand. The control fetches the instruction from memory and its address part to reaccess the memory that stores the effective address. Means here it is saying that in addressing mode we specified it contains effective address. In that effective address we'll get the operand. Means we'll get the data. We can fetch the data. This addressing mode slows down the execution as it requires multiple memory lookups to find the operand. For example, if you take add A comma B, here A is kept in braces, means it refers to the addressing mode, means it refers to it has effective address, it contains effective address in it. So the memory location A contains effective address of the operand. It goes to that particular location and operand in it is added to the operand of location B. And finally, we know that the result is stored in B itself. Next. Registered direct addressing mode. Registered direct addressing mode is nothing like direct addressing mode, but there is a small difference in it. The operands that reside within the CPU are stored in registers. But we have seen in direct addressing mode, the operand is stored in memory locations. The specific register is selected from the address field in the instruction. No reference to the memory is required to fetch the operand. Means we didn't use any memory locations. We didn't use any references to memory. The only difference between direct addressing mode and the register addressing mode is that the instruction address field refers to the CPU register instead of the main memory. It's the only difference between direct addressing mode and register direct addressing mode. Now, let us see the advantage of this. This mode provides faster memory access to the operands. And disadvantage is it has limited address space, and using multiple registers can help boost the performance, but it complicates the instructions. Examples: add R1 comma R2. Operand at R1 is added with operand at R2, and the result is stored in R2 again. Now let us see register indirect addressing mode. The address field of instruction defines a register in the CPU that stores the effective address of the operand in memory. Only one reference to the memory is required to fetch the operand. The specified register contains the address of the operand instead of the operand. The only difference between the indirect addressing mode and the register addressing mode is instruction address field refers to a CPU register. For example, if you take add R1 comma R2, R1 memory location consists of EA of operand. The R and the data in that effective address is added with the data in R2, and the result is stored in R2. In this also, we use one memory location, one reference to memory location, and one reference to registers. So, as we have seen, direct and indirect addressing modes along with register direct and register indirect, right? In direct, we use one reference to memory location. In indirect, we use two references to memory locations. In register direct, we didn't use any memory locations references. And in register indirect, we use one memory location reference. Thank you.